Welcome everyone to this session, Analyzing Innovative Technologies, and that's session D412, Virtual Room 2. And my name is Anja Maier. I'm Professor of Engineering Systems Design at DTU-Technical University of Denmark, and I'll be your session chair for this hour. I guess we are by now rather used to how this works. The organizing team has done a fantastic job in getting us all ready and having discussions and sharing our work. So just a quick reminder, we have 9 spaces for people to share audio and video, and so there's 2 left in case someone would like to, in the discussion session, come on with their video. It's possible. I will run the session such that I'll introduce the speakers. We have 5 presentations today. I'll introduce the speakers, then the video will be played, another introduction to the second paper, and so on and so forth. And then we'll have I believe, about 30 minutes to enter into dialogue. So whilst the audio-video recordings are running, please do begin to submit your thoughts and questions through the chat, and I will pick them up as we go along. And this goes for everyone, the authors, the participants, the panelists, well, that's the authors, and technical support. You're very much welcome also. You're part of the team. Okay, now I believe we can just go ahead. People are used to the way it's run. Let us start with paper number 1. So the paper title is Assessing the Future Methods and Criteria, and it's presented by Henrik Thiele. Henrik is a PhD student at Paderborn University Heinz Nixdorf Institute at the chair of product creation. And he comes with a background in applied mathematics. His research topics are strategic planning, scenario technique, and that within also the wider context of innovation management. So, welcome, Henrik, and the stage is yours.
Hello, and welcome to my talk, Assessing the Future Methods and Criteria. Today, I will talk about methods of analyzing the future and how to apply them. First of all, what is looking into the future? There's 2 types of methods in general, which is forecasting and then foresight. While forecast, like a weather forecast, tries to predict the most exact and most probable future, foresight methods focus on a consistent, possible, or feasible future, which helps build strategies and discover new technology fields, for example. If we look at the timeline, there are 4 different generations coming from early warning, which is trend extrapolation or extrapolation in general, up to the 4th generation where we are at now, which is strategic foresight, which is an integrative approach within one's company. If we look in general at the methods of looking into the future, we have those which actually look into the future, starting from causal logics, which could be simulations, time series, which is mostly trend extrapolation, laws and theory, for example, the S-curve analysis of a technology, fantasy and creativity. One method could be fantasy, or shaping, meaning conclusions. A method which lies between all those and mixes them would be the scenario technique. Methods of analyzing the present, like pattern analysis, can be used as looking into the futures, but are analyzing only the present, as well as methods of forming an opinion, which could be expert panels. If we list these, we can then associate the methods used and then the methods most often used. If I say most often, we performed a meta-study, looked at over 5,000 different mutually exclusive cases applied in industry in those different cases, and highlighted those most often used, while listing also those methods used in general. To determine which method to apply, we also looked at criteria and clustered them to see what would be good criteria of applying methods. If you look into the literature, most often these criteria and methods are used in graphic plots, where, for example, the foresight time span is listed against the quality of input data. Here, qualitative to quantitative data, and then showing which methods lie in between those. We assembled all those criteria, clustered them, and then landed on one big table where we see up above the types of methods, and then on the left, the criteria we can use, and then actually went into them in the middle and said for each type of method what specification is made. So going into looking at environment of the future, the input, and then the methodological approaches, you can then determine what method to use. Within the environment of the future, examples are given: the scope you want to achieve, the time frame, the speed, the change of the future you're looking at, the turbulence, and the uncertainty. This is to be assessed first. Then you have to look into the input you can give, which is the nature of the input, the amount of data you have, the knowledge of the future, and the orientation where you want to look at. And in the end, the methodological aspects, the purpose, the methodological, the effort, the team, the tools used, and then the criteria to achieve your output in which you want to have it. So by applying and going through those steps, you can, for your organization, choose the right methods. Thank you for your attention, and I'm looking forward to an interesting discussions and many questions about our research.
Yeah, thank you, Henrik. I guess we're all along the way giving virtual applauses here. Now, let us keep with this idea of continuing the introduction of the authors and the videos. Petter appears to be off the screen right now, but I'm sure he's getting back when it comes to the dialogue he was in before. So I will just introduce him and his work. And that is a great pleasure also. I've just received a message that his paper is one of the reviewers' favorite, has won one of the reviewers' favorite awards as the top 10% related papers by the reviewer score, best related. So now the title of his work is A Framework for Technology-Driven Design, Criticality and Comfort Zone for Emerging Technologies. He is currently Professor in Fluid and Mechatronics Systems at Linköping University in Sweden, where he was prior to that also Professor in Machine Design. He currently also holds an appointment as Swedish Endowed Chair part-time at the Federal University of ABC in Brazil, and they are at the Technical Aeronautics Institute. And Petter comes with a background in mechanical engineering. So let us start his presentation.
Hi, my name is Petter Krus. I'm from Linköping University in Sweden. This paper is done together with Luciana Pereira from UFLC in Brazil. It's about a framework for technology-driven design, criticality and comfort zone for emerging technologies. Requirements for sustainable system often means that new technology solutions need to be introduced. Our assumption is that first we need to determine the specific set of viable requirements for a technology. In the requirement space, we define a technology comfort zone where the technology can readily be used. We have the technology sensitive zone where the product benefits strongly from technology improvements. And then we have the technology critical zone where technology needs to be developed to be useful for the product. This is used to map requirements where feasible project can be realized. Usually the design process is described like this. We have customer requirements that are transformed into functional requirements, which are then used to define the design and the design parameters. With this framework, we propose that we have technology characteristics that are transformed into requirement space, which then should be combined with customer requirement to form viable products. An important aspect of technology is its sensitivity from design parameters to performance and also to cost. And we can introduce a cost-benefit factor as a quotient of these two. This says how many percent the performance can be increased if cost is increased 1%. To demonstrate the use of the concept, we look at electric cars. And here we can model them using existing data and then make a regression model of that. The regression models show the relationship between vehicle mass and energy consumption, and vehicle mass excluding batteries and cost. So we get these two expressions. These expressions can then be combined to form the cost-benefit factor. We can then plot this cost-benefit factor against the vehicle mass excluding batteries and the battery fraction, and then plot also where we have the existing cars. And we see that all of them are inside this technology comfort zone, which we define for a kappa value of greater than 3. We can also plot the range, of course. This is particularly interesting if you combine this with technology forecasting, where we look at what happened with energy density and cost in the future. We see that in 2024, we open up a new area here for smaller cars and cars with larger range than before. This concept can be used to calculate the cost-benefit factor of an electric aircraft powered by batteries. The range equation can be seen here. It's simply a function of the aerodynamic quantity, which is L over D, the lift over drag. This can be like 20 for a good aircraft. We have the battery efficiency here and the propulsive efficiency here. Here we have the battery weight divided by the takeoff weight. We introduce the quotient between battery weight and takeoff weight minus batteries as a design parameter. The range can then be calculated like this. If you assume the cost is proportional to takeoff weight, we can establish the cost-benefit factors as 1 over the design parameter. Using this expression, we can calculate the cost-benefit factor as a function of range. And as you can see, we have a very limited range at present technology. It's 250 kilometers if you want to stay in the technology comfort zone, and 560 if we go to technology critical. And that here, half of the aircraft takeoff weight is batteries. And it also doesn't include any reserves, like reaching an alternative airport or 45 minutes extra loitering time, which is required. So in reality, we have a very limited range for a battery-powered aircraft. Conclusions. In this paper, we have introduced the concept of the cost-benefit factor, which is used to define technology comfort zone, technology sensitive zone, and technology critical zone. Thank you for your attention.
Yes, thank you, Petter, and congratulations on your Reviewer's Favorite Award. I think you entered the session again. I hope you can hear us, see the screen. Please do request to share your screen as well. Now we continue towards our third presentation. And the title here is Managing Disruptive Innovation by Value-Oriented Portfolio Planning. The author is, or the first author is, and presenter is Simon Weinreich. He is PhD student at the Institute of Engineering Design at the Technical University of Braunschweig, and he's also employed as a doctoral candidate in the strategy department of Volkswagen AG in Wolfsburg. His research focus is on a holistic evaluation of innovation, and that with a particular focus on disruptive innovation or potentially disruptive innovation. That's my notes. I think he has written what his background is. Apologies, my scribbling hand notes. I think it's from, anyway, he'll say himself when he speaks what his disciplinary background is. Now we know he's at Braunschweig and at the same time at Volkswagen, and we're very much looking forward to his work. Off we go.
Hello there, I'm Simon Weinreich and I'm a PhD student at Technische Universität Braunschweig in Germany at the Institute of Engineering Design of Professor Vietor. My research is about how disruptive innovations can be implemented in portfolio planning. So, in this presentation, I firstly want to show you why this question is relevant. Then I will go into the state of the art, followed by the results of a systematic literature analysis. And finally, I will describe the developed framework and further research needs. Today, markets are characterized by high dynamics. This favors the appearance of highly new innovations, thus also disruptive innovations, short DI. DI have the potential to change markets and can be the existential threat, especially to established companies. So the question arises if companies are able to create DI proactively to be the disruptor and not the disrupted. This contribution links the disciplines of DI and IPM as seen in the right figure. To create this connection, the orientation towards customer value is presented and the following two steps result. First, identifying the disruptive potential of product ideas, and second, evaluating them by an approach that is suitable for various product ideas. In the following, I will present these disciplines in more detail. DI cause a transformation of the market that can be unpredictable and address new and unserved customer needs. One of the main characteristics of DI is that they are valued differently by the customer compared to other innovations. For example, not existing mainstream customers, but new customers value the features offered by DI because they help them fulfilling their goals. So what approaches exist to evaluate innovation potential? In IPM, new and existing product ideas are evaluated, which is mainly structured in the categories strategic fit, balance, and value maximization. Strategic fit indicates that the product ideas should be aligned with the corporate strategy. Balance means that all product ideas should be considered, so DI simultaneously to others. This is challenging because different characteristics of innovations may be conflicting. Value maximization aims to maximize value, which is divided into customer and business value. Business value is mainly applied in practice due to its user-friendliness, for example, by financial methods. These methods require detailed data, which is often not available for DI due to their high degree of novelty. So, research provides extensive methods for evaluating different product types, but not a standardized evaluation approach valid for every innovation type due to their complexity. Here, research suggests to adapt IPM methods to specific innovation types, for example, to consider disruptive innovations. Are there disciplines in research that can be used to create these adapted approaches? One is value orientation by Woodruff. Here, value can be understood as a customer's perceived preference of products. Woodruff defined 3 levels of customer value in his hierarchy model. Customer goals determine use situations, which influence the way customers perceive product attributes. We've seen that DI also address customers' goals. So, roughly said, value concepts, especially from a customer's perspective, can be applied to DI, especially on the higher levels. Based on the presented understanding of DI, IPM, and value, we conducted a systematic literature review. For this purpose, we defined requirements that an IPM approach for innovation valuation has to meet to be capable of DI. The requirements are shown in the table on the left side. The content is here, for example, that different types of product ideas should be considered simultaneously, or that higher levels of customer value should be included. The columns on the right side show the analyzed IPM approaches. Due to the short time available in this presentation, I will focus on the key results. In general, it could be confirmed that there is currently no approach to consider DI and IPM. In concrete terms, This means that existing approaches, for example, focus primarily on a company perspective, for example, business value via financial methods, which is not appropriate for DI. Customer value is included in the evaluation primarily as an exclusion criterion. In other words, it is more a question of whether a product idea serves customer needs and not how much, or even at what value levels. To roughly address this research gap, a framework was developed to put the considered aspects into an overall context and to show their interrelations. The figure shows the evaluation process in IPM and goes into detail which aspects have to be considered. You can read a more detailed explanation in the paper. Further research need is mainly focused on the description of customer value, for example, to use it as an evaluation criterion. Please do not hesitate to contact me in case of any other questions. You can find my contact data on the lower right. And finally, thank you very much for your interest and attention.
Thank you, Simon. I can also see there's some questions already. That is great. Keep them coming. Now, let's go to presentation number 3 and number 4. Presentation number 4. And the title is Identifying Gaps in Automating the Assessment of Technology Readiness Levels. The presenter is Safa Faidi from the University of Toronto, and they are particularly from the Mechanical Industrial Engineering Department. She is studying the potential improvements in the Technology Readiness Level scale. Welcome, and off your video goes.
Hi, my name is Safa Faidi, and on behalf of myself and Dr. Alison Olechowski, I will be presenting our research on identifying gaps in automating the assessment of technology readiness levels. The Technology Readiness Level Scale was developed by NASA in the 1970s as a way to quantify technology maturity and assess its risk. The scale consists of 9 levels, with maturity increasing in the direction shown by the arrow to the right of the figure. A technology of tier L1 is a technology of lowest maturity and highest risk, and is defined as a technology whose basic principles have been observed and reported. While a technology of tier L9 is a technology of highest maturity and lowest risk, and is defined as a technology whose actual system was proven in an operational environment. Although the scale was developed primarily for NASA space missions, it has made its way to industries like manufacturing and biotechnology, and is currently widely used as a risk assessment tool by tech businesses. Previous research highlights that TRL assessment is prone to subjectivity and bias. One reason for this is that the assessments are based on expert opinion rather than a repeatable evidence-based methodology. These issues push decision-making to be more time-consuming and often based on inaccurate input. Automating the TRL scale can provide a non-biased, objective, and repeatable method to assess technologies. Automation could also drastically decrease the time it would take to assess a technology. Existing models attempted to automate technology assessments by analyzing data from scientific literature, patents in use, and matching the trends in data to the corresponding TRL. The method is based on the previous assumption used by most technology forecasting and assessment models that state that as technologies progress in their maturity from being, emerging, to growing, to mature, their activity changes from being discussed in scientific publications, to patents, to news and media. Our research aimed to investigate whether the literature is correct in pairing specific data sets to specific levels of maturity. We specifically looked at emerging technologies to investigate whether the majority of technology record activity manifests in scientific publications. To address the research question, we collected technology records from scientific publications, patents, and news for 15 emerging nanotechnologies. These technologies were TRL assessed by NASA's Technology Roadmap Report in 2015. The records collected were from 2009 to 2015. The scientific publications, patents, and news records were all collected using a commercial analytics software called MergeFlow. MergeFlow's databases include PubMed, worldwide patent offices, and worldwide business news from different industries. I will now present the highlights of the results. This graph shows the data for scientific publications for 5 TRL3 nanotechnologies from the year 2009 to 2015. As shown in the figure, we can see an increased trend in most technologies as they reach their assessment year in 2015. This trend in scientific publications is expected for emerging technologies, those with low TRLs, and confirmed by existing technology assessment and forecasting literature. These two graphs show the data for industry news and patent activity for the same 5 TRL3 nanotechnologies from the year 2009 to 2015. We also see an increased trend in some technologies as they reach their assessment year in 2015. These trends in industry news and patents for emerging technologies do not agree with the current assumptions made by technology assessment and forecasting literature, which often excludes analyzing these datasets for emerging technologies. These results show that the literature is not correct in pairing specific datasets to specific levels of maturity. These findings can help us build more accurate automated TRL models by changing previous and outdated assumptions of technology behavior. Since this paper was published, we have highlighted more gaps and challenges of automating the TRL assessment, and we are ready to offer potential alternatives and solutions that don't rely on the same flawed assumption of the current bibliometrics method. Please get in touch with us to find out more about the alternatives and solutions. Thank you for listening, and please feel free to contact us with any questions or comments you may have.
Thank you, Safa and Alison. A virtual round of applause here as well. Now, let us home in on presentation number 5, also the final presentation of this session. It links to presentation number 1, both in, well, it links to all in terms of theme, but in terms of co-author also to the first one. The author here is Philipp Scholle. He is a PhD student at Paderborn University, Heinz-Nixdorf Institute, and also the chair of product creation. His research scope is strategic planning with scenario technique, and here in a particular application on requirements engineering. That's also where it nicely links to presentation number 2. Now, the title here is Improving Scenario Technique by Semi-Automized Consistency Assessment Based on Pattern Recognition by Artificial Neural Networks. Philipp is not here as we hear. However, as said, the co-author is here. So we have all the expertise in the room. Philipp, off you go, virtually.
My name is Philipp Scholle, and by semi-automized based on pattern recognition by artificial neural networks. So what am I going to do? We're talking about scenario technique, so assessing future scenarios for market development, for technological development, for societal development, or probably even for that pandemic we're in right here, for future growth. And Gräßler and myself published that adding the model for scenario in 2017 and the 4th step consistency assessment. It's really worth looking at it because it costs quite a lot of effort and we want to prioritize that step. In that step, there's the assessment between the influence factors. Influence factors are factors which are describing our field for the scenario development. An influence factor, saying nowadays terms, could be the number of infected persons infected with COVID-19. And there are future developments for that factor. They could increase, they could stagnate or decrease. Another influence factor could be the number of used intensive care hospital beds or the availability of a vaccine against the virus. And we want to semi-automatize that step. And the research questions we're tackling in our world are: can generic groups of consistency values, we call them consistency values, be identified? How can consistency values within a consistency matrix be classified into these patterns efficiently? And in which way can semi-automatized consistency be improved by these consistency patterns? The approach we chose is a DRM approach based on the work by Alison and Faidi, combined with a case study approach, where we asked 100 students to fill out these matrices and analyze them and derive our consistency patterns. So if we look at these matrices, we want to abstract them. So we want to have an assessment for all the projections of a single influence factor related to all the projections of another influence factor, having some kind of more general overview. And what we found out is there are certain types of users, and they tend towards either a proportional, an anti-proportional, or a non-consistency assessment. And we identified, based on the diagonal and the counter-diagonal of these submodules, identified 6 consistency patterns from a supporting, which is the proportional behavior, the contrary, which is the anti-proportional behavior, towards a neutral, non-specific. And there are actually certain user groups which are tending towards either predominantly using a supporting type of consistency patterns, and others which are predominantly using the neutral type. So the idea is to use that classification for improving the semi-automatized consistency assessment. We then used a neural network in training all of these, training the network to automatically assign the consistency identified and classify them automatically. So give the network a matrix, and it will automatically classify the dominant consistency type. And we then use these consistency types as an input to a rule base to automatically assess the consistency values. So if we look at the triangular relations, for example, if we know the consistency type between the number of infected persons and the number of required hospital beds, and we then know the consistency type between the availability of a vaccine against the coronavirus and the number of infected persons, we could actually semi-automatically assess the consistency type between the availability of a vaccine against the virus towards the number of used intensive care hospital beds. This is the rule base we've just developed, which you could use for semi-automatically assessing the consistency matrix and semi-automatically filling it. So really reducing the effort. We then put in another paper, and this is like work in progress by now, into a broader context. So what we actually do is we segment the consistency matrix, we generate submatrices, we identify our consistency patterns, then we identify the predominant user type, we use a specific neural network for the semi-automatized consistency assessment, which is the second last step, and then we actually to generate all the submatrices from the consistency patterns later on, which is really improving, and is like if you use other data for validations, like an 80% chance of really generating the correct values from just 2/3 of the input values. So it's like really improving the efficiency of that process. So just to give you a brief summary and outline of the very short presentation, just start with the agile procedural model for scenario technique. We then identified consistency patterns in a case study-based approach, developed a method for a semi-automatized consistency assessment, and there's a little bit of work to be done in the future. You could actually improve the performance by either using further case study and further study data, and improve the neural network architecture. So just a very brief introduction into our work. So thank you very much, and I'm looking forward for your questions now. Thank you.
Yes, thank you, Philipp. Somewhere in virtual space, I think for all of us, this was an exercise in trying to forecast what might be said. Now, a really good set of presentations connecting amongst each other quite nicely in terms of methodologies used, in terms of application areas, requirements, in terms of possibly data mining opportunities. Now, I see 2 questions being submitted already. Please use the opportunity to submit some further thoughts. I would like to post one from my side as chair to all of you before we begin with the one submitted through the chat. And if possible, maybe the technology has a bit of a hiccup. Simon, I saw you briefly with a camera. I think you're trying, but at least you're online. Petter, I wonder whether you could submit another request for sharing your video audio once more. Okay, now, so we have heard a number of ways of how to potentially look into the future in terms of what technologies might there be, how might they be used, what effect might they have in various ways. What I would like you to do before we start is, what is your understanding? What is a technology in your method? Safa had some pointers, but I would like everyone just to give us an idea of what do we mean by technology. As the literature is actually a bit split on that terminology. So whilst we're thinking of further questions, please, who from the panelists would like to go ahead beginning to answer? What is a technology, or innovative technology in this case even?
That Henrik here. I hope you can hear me. Tech for me is more defined by what you would look at, and especially looking at foresighting methods. I think it's a lot broader. The definition is a lot broader than you would find in a very technical sense. And for me, a technology in that sense, when looking and when foresighting, also includes everything around a very stiff definition and includes societal effects and opinions and all that. Because I think when we talk about applying technologies, and convincing people to use technologies, all these effects have to be taken into account, and not only the physical laws and technical rules that lie behind the technology are there to be assessed. Looking, for example, at electric cars, that the usage and the decision to buy electric cars was not only based on the possibility of having the car, but also on, is it cool? Do I want to use it? And a certain way of Elon Musk presenting products. And for me, technology in my foresighting sense also should include these aspects, but that's only in this sense and not in the definition of a technology.
Mm-hmm. All right, let's hear some other of the authors define what they mean by technology, because this sets quite a path. If you use a certain technique and you have your boundary, what you're looking for, this gives a certain answer. So this was a very broad spectrum from Henrik. Where do we stand with Simon, Safa, Petra?
I think, so for my research, I've been essentially trying to define how we specifically define what a mature technology is, because when we talk about the technology readiness level scale, if we're looking at what a technology of TRL 9 is, that's a mature technology. Mm-hmm. And it's very tough for you to pinpoint exactly what we mean with a mature technology. And one part of our research was to essentially ask expert opinion, or basically ask industry people what they thought of mature technologies is. And sometimes we tend to just look at what technologies are from a sense of commercially available technologies. So if a technology is commercially available, that's essentially what a TRL 9 or mature technology is. But I think my answer would be that it's pretty tough to define exactly what you mean with a technology in that sense.
Yeah. Okay, thank you. Because we have quite a wide spectrum, right? I mean, yours is then when the technology is there and you assess it. Emerging technologies, there might be, it's not yet materialized into a product, for example. Okay, now I see more online. Simon, what would be your definition behind the technology that's lying underneath your paper?
Yeah, I'm in the context of disruptive innovation. Yep. And I got a very short explanation what I can understand under technologies. So two main vocabularies or two main phrases are innovation and technologies for me. So the innovation is like a more broader sense, where the innovation can be perceivable by the customer. So the innovation distributes the function the customer can use. But how
the functionality of the product is distributed to the customer. That's the way a technology works. So to give one example, the innovation is like the digital camera, and the technology behind it is like the digital chip or like the digitization to make it possible that you can offer a digital camera.
Okay. Yep. Yes. Is that a way to connect to Peter? What your definition of technology would be?
I could say technologies maybe was preventing me from sharing my video, but I think in general technology is what enables you to create functions. That is, it is like the underlying stuff needed to provide the functionality in the product.
Okay, yeah, so that would be included in your definition, right? Because that I think gives a good impression both towards the spectrum as well as the inherent actually difficulty of defining technology. We've done also some work in my group, and this is really tricky. And this, why I'm asking it is because now we get to the questions of the audience, and they relate also a lot to who uses the technologies, who uses the foresight techniques. And so this has a direct link. Now let's go here to, let's take Ola Isaksson's question first. This one goes to Henrik, and you started a little bit in your answer already. So Ola asks, where, how do you include global and societal phenomena and their impact on the technology studied? So it's this way around. If I remember correctly, Henrik mentioned the sort of societal phenomena as part of the technology, but it's also how do they impact the technology studied, demographics, climate change, and what might be a long-term prognosis here. So these are actually two questions. Would you want to give it a shot, Henrik?
Yeah, I will try to. First of all, there are methods, and when we're looking at fantasy or laws and theory methods, and that actually use these trends, mega trend methods, where you actually go from the trends and then try to derive new ideas and scenarios starting from that. So that is one part of the answer. And the other one is that exactly these trends can play a part in the input data you use for your methods. For example, if we look at scenario technique, it's consistency-based scenario techniques, you select different input variables, influencing factors, and one of these can be exactly these global trends. But the overall answer is it also always connects with what is your scope and what is your aim of looking into the future. And by defining that aim and that goal and looking at how do I want to, what space in the future do I want to have, what do I want to look at, these can be included as influencing factors and or not. And the main result of the research was this big table on how to define and then select my method of looking into the future by looking at what amount of data do I have available, who are the people that are in my group of actually deriving pictures of the future. So yes, it doesn't have to be. Depending on the method, I strongly recommend to include these factors, or I don't.
Okay. Yes, thank you for that. You mentioned data. I see also Peter possibly wanted to answer here.
Yeah, I can. Right? I can say.
I see your microphone lighting up. So.
Okay. Yeah, I think these societal and global phenomena, they are really what are pushing the the boundaries and the requirements. And that's one of the things I was having in mind when I thought that we should look at the requirement space where we can use the technology. And that is really to be, since these requirements are rapidly changing now.
Yeah. I mean, there's also a fine line between a trend and a technology, right? I mean, digitalization, it's a trend. It's maybe also lots of technologies and so on and so forth. So it's quite tricky, I think, to delineate. Again, I've said it before, but that's important when we use methods, that we know what we're fishing for, literally. Henrik mentioned data. And also, in Petter's presentation and in all presentations, Safa's, we're all dependent on data. So could we have a question or answers here saying, how do we mine for data? And what might be the future here for data that informs the method, so the content about the technologies in the scenario technique or other method?
One thing you see is that there is a value to this data, and that is data that value is maybe increasing. But for instance, if you look at the aeronautics industry, they have a lot of in-house data from previous projects, etc., which give them can give them good guidance in future projects. But and that is quite closely guarded also. So. Yeah.
I mean, it also links nicely to Safa, and there's a question for Safa as well. There are ways of automating or mining open data sources, for example, looking at Twitter feed, looking at other ways of getting sort of a bottom-up feel or a temperature check, if you like, for what technologies are emerging, what's in the discussion, patents, mining projects, publications, and so on. So maybe we link in that way to Safa. There's a question directly to you by Andreas Hein. How would you expect your results to change if you choose a different technology set, possibly from a different organization with a different TRL assessment approach? So yes, that's very nicely getting a bit under the hood of TRL as a method.
Yeah. So for the paper, we did pick nanotechnologies, but you know, my research as a whole looked at technologies from different areas. And one thing that we find is when we're talking about nanotechnology versus, for instance, biotech, you do see that sometimes there are technology areas that have more hype associated with them. And what hype really means is basically some technologies are just naturally more popular in news or scientific publications just because they're more well-funded, more interesting to discuss. And that's where I think that's where our results change. And this is one of the reasons why we can't just simply rely on numbers. We can't just simply say that if a technology shows more activity in a specific data set, this is a reflection of its maturity. It's a lot more complex than that. Yeah.
Okay. Yeah. That's also nice to show the spectrum. I mean, one is the data that informs your method, then the output from the method, and then your assessment of the technology. So there's quite some decision gates in between. I also see that's getting back to Henrik once more, and that is a question from Simon Weinreich. I need to foresight when an innovation will be accepted by the customer. So is this in the scope of your research, and may you have a solution for this?
I think the when is very difficult, but if we take the when, and I'm taking this answer a little bit further, and say it's a typo and it would be a whether or an if, then I think yes, because then you would derive scenarios of where the innovation would be placed in the future, what it can yield, and then you can derive with other methods that we know, like user stories or personas, actually from the future personas or future pictures, then the criteria of how
how your innovation will be used, and what criteria are for the innovation to be accepted. So when I don't think that you would be very successful, but for if and a whether, there are very suitable methods, and we can connect on a direct level, and we can talk about it easily in German. But yeah, I think when not that possible, if and whether, yes.
Well, thanks, Henrik.
Yes, great. And also, I see in the chat there's some pointers also to papers, foresight papers. So please pick those up. They could be very useful in this context. I also shamelessly plug one website where we look into disruptive technologies. So now I'm hearing many good points on how we might get our information, what are the challenges. If we then link up to the question that was just last answered, and that links then to the customer or to the recipient. So who uses the technologies is one big question, but I'm thinking even who uses the scenario techniques, the road mapping techniques, the TRL assessments, and so on and so forth. Could the panelists give us some insight into who are the recipients of their papers? So who do you want to use your technique? Maybe we start with Simon.
Of course. So the motivation for my paper was I looked a YouTube video about Kodak, and I found out that Kodak, who is insolvent now, one developer at Kodak developed the digital camera, but Kodak did not mention this potential, did not indicate this potential in the correct way. So my technique aims at the portfolio manager who decides whether technology or what innovation you have to bring into its development.
Yeah, so that's on a strategic level, let's say for the whole company.
Right.
Do we join in with Simon's answer from the other speakers and their methods, or their research into the methods? Safa?
What the picture of my
okay. Maybe Henrik.
Sorry,
go, Henrik.
You're lagging like 5 seconds in my thing. What I want to focus on in my broader research I'm conducting is to enable basically everyone, saying at every company size, to do foresight methods, as a lot of methods are very dependent on specific people or with knowledge in methods, and then the requirement to often take in external consultancies. So the broader picture is to enable also SMEs and smaller companies to use foresight methods, and this is a step of enabling people to select a method and seeing what resources do they need, and then the second step is actually developing methods that are not that resource extensive.
Okay, so we have the portfolio manager, then we have generally categories of companies, not necessarily a specific role in a company. Where do Safa, Petter?
Yeah, I think for the technology readiness levels, in terms of who would use the automated version, is essentially anyone really curious about assessing their technology's maturity using the TRL scale. So when we first started the research, Merschel, the company I mentioned in my presentation, who's an analytics company in Germany, lots of companies use their software to collect data from data sets like venture capital, clinical trials, scientific applications, patents, in order to assess basically where that technology stands. And the founder let us know that there's actually a lot of interest in people when they're searching for these technologies to have that number that basically puts the technology's maturity with, you know, a specific category. So a technology that is a TRL3 maybe is worth investing in, maybe not worth investing in as a technology of like TRL maybe 6 or 7. And yeah, so it's essentially anyone who's curious about onboarding technologies onto their company or onto their product, who's curious about assessing the technology's risk as well.
Yeah, okay. So that's particular roles. Petter, last one. Who is the recipient of your paper, of your work? Okay. Yeah, then we'll just move on. We have space for 1 or 2 more questions, and also from the panelists to each other. Please submit it through the chat. Where I was getting at with my question here is to think, how might we as design researchers / into the innovation space enable perhaps actually designers as strategists in the company to foresee what's coming and what they can use in going forward. So it's interesting to hear that the speakers don't necessarily immediately have the designer or developer as the prime target audience.
Yeah. Could I had my mic muted, sorry.
Okay.
When it comes to my think is the strategic, make the strategic decision for technologies. These are the people we want to address. Thank you.
Yeah. Okay. Yeah, that's great. Yeah, I think, I mean, it's a bit, I guess, my hobby horse in some ways to say design. I really believe that as designers or designing, we have a very strong role in creating the future, and we can set a bit the agenda in some ways, of course, influenced by the trends, as Ola mentioned, but still. And so if we as researchers find a way to enable the designer using what you say, so as an aspiration of really helping the next generation design engineers to think differently, I think we can help many companies and thereby society. Now, can we have one more question, perhaps from the panelists to each other? And I encourage you all to read the papers. They're very insightful. And there's also previous work, in fact, in the Design Society Conference series not too long ago, and perhaps in your future iteration of the paper, do cite those works. Yes.
Yeah.
Okay.
I can have a question for all of us.
Yeah.
I find that usually it's you can find quite good predictions when you read the past literature, but what they usually get wrong is the timing. Some things go much faster than we think, and some things take much longer.
Yeah, that's interesting. So, I mean, one is mining for the trends and conceptualizing more specifically the technology and the use, but the other is then when and how. And yeah, it's also very interesting. I found from Safa also, and the last presentation, all of them, but these particularly looking into automation of the data mining and the opportunities that come here working with data scientists also. That's, I think, also for our community, a very rich source to draw in, to tap into. Good. Okay. Then, unless someone has a burning thought and question, we can, of course, take a lot offline now. We have heard. I would like to thank, in particular, the speakers, the authors all together, and also the audience for sharing their question, listening, their comments through the chat, and last but not least, the technical support behind all this, that it worked so well. Thank you, everyone, and have a lovely remainder of the conference. See you possibly later in the closing or in the social space. All the best for your research. See you again.
Thank you so much.
Thanks, Anja.
Thank you. Bye. Thank you for the question.
Bye for now.